Hello guys, welcome back to the quantity solving workshop. My name is Vincent. If you're a returning subscriber, thank you for coming back, and if you're a new subscriber, you're very much welcome. Please don't forget to like, share and subscribe to the channel to help the channel grow. We are looking at hitting a milestone of 3,000 subscribers before the end of the year, so your subscription will be very important and beneficial to this channel. If my voice is a bit shaky, I'm not feeling too well, so I'm having catarrh, so please pardon me for any breaking transmission. In today's video, we're going to be treating how to go about the measurements for structural steel. So this video is going to be like an introduction for the measurements, so it's going to be a practical introduction, because after here I'm going to be taking you to where there is a structure made of structural steel, and I'm going to be breaking down all the members and how you go about measuring structural steel. The method or the way you measure for structural steel work is going to be the same irrespective of whatever structure you are constructing with the structural steel, be it a water tank stand, a roof, a staircase. As far as you understand the process of measuring for one, you can use that process to go about measuring for the others, and it is a very simple process. First and foremost, there are different types of structural steel. There's I section, there's L section, there's C section, there's Z section. So whatever the kind of section used, you specify it in your measurement, right? And irrespective of whether it is a C section, L section or I section, the method of going about the measurement for this kind of structural steel is the same. So for this video, we're going to be using a water tank stand as an example. And another thing you need to know is that according to the standard method of measurement, there are other items that you also measure while measuring your structural steel. So the structural steel is one. Then you are going to be measuring for fittings that are used to construct the structural steel. You're going to be measuring for, I think, hold down bolts and special bolts. There's a difference between hold down bolts and special bolts. Hold down bolt is used to hold the massive structure. That's when you finish constructing everything. The hold down bolt is used to hold that structure or to connect that structure directly into a plinth, right? Don't worry, by the time you go to the site where the structure is located, you're going to see everything practically. Why the special bolt is like another type of bolt that is used to connect other members within the structure. Like for example, if you want to brace the main stanchions or columns in the structural steel, or in the, let's just say, in the water tank stand, you might need to connect all these bracing members together, and there are different connections. You can do riveting, you can use bolts and nuts, you can weld them. So they are different depending on your budget and what the engineer has already specified in the drawing. So that is under special connections, that's special bolts. The next item on the standard method of measurement is the fittings, right? So these fittings are just smaller members that are used to connect the major members together. And the example of this fitting is the base plates, the gusset plates, and in some cases cleat angles, right? So there are other fittings though, but these are the few I can remember. So the base plate is just a spherical plate, square or rectangular plate, that is placed on the plinth before you can now start constructing the stanchions that will give you the whole water tank stand. While the gusset plate looks like a base plate, but it does not serve the function as a base plate. But the gusset plate helps to provide like a surface for welding, different members together. That's the purpose of a gusset plate. Cleat angle. So the cleat angle looks like an L shape. That also helps to provide a surface where you can connect two different members together at an angle. So if there's a member coming vertically, the cleat angle is like an L shape, right? So if there's a member coming like this and you place the cleat angle here, you can bolt or weld the member that is coming vertically. And also if there's a member under that's horizontal, you can also bolt the member to the cleat angle. So those are basically the major fittings that we have, and then maybe You can have a gauze net that will use as a surface or a base for where the tank will stand. It can be a gauze net or it can be steel. Yes, it can also be steel, just weld steel at the top, and then the water tank can sit on it. Then there are other members or sub members that make up the water tank stand. For example, the ladder and the railings at the top of the water tank, right? So that in case there is need for maintenance, whoever is going to carry out the maintenance will not fall off. So there are guardrails at the side, so you have to also measure for them, and the balusters that are supporting the guardrail. So that is basically it. So when it comes to the measurement, the main steel work for the structural steel, they are measured in tons. And since they are measured in tons, like I said before when we were measuring reinforcement, right, to know how you are going to go about measuring these items, go and check the units for each of their weights. I don't know, let me come again. To measure each of these structural steel, check the weights of each of this steel. Because for example, now the steel, the size of or the weight of the steel we use for the column might be different from the size of the steel used for maybe the beams on the water tank stand. So these are the important things you have to take note of, right? So you check the weight. Now this weight can come in kg per meter, it can come in kg per meter square, it can come in kg per meter cube, right? So if it is kg per meter, know that you are measuring that member in linear meters first, then you convert it to kg, and then you convert it to what? Tons. If the weight of the member is in kg per meter square, like for most of the fittings, like the base plates and the gauze plates, you have to measure the member first in meter square, convert it to kg, and then convert it to tons. And similarly, if the item is kg per meter cube, then it means that you have to measure the volume of the member, convert it to kg, and then convert it to what? Tons. It's as simple as that. As for other members, like the hold arm bolt is measured in number, the special bolt measured in number. So that's just basically what you need to understand to measure structural steel. As for how to go about the conversion from meters to kg and to tons, I've done all those things when I was talking about reinforcement, so you can go and check those videos. So I don't want to make this video long because I don't know, the retention on my videos, because of they are too long, has been going down. So I'm trying to make sure that my videos are short, between 15 to 20 minutes max. And with this being said, we're going to be going to this the area where the structural steel work for the water tank stand was constructed. Okay, so guys, as you can see, this is the water tank stand that was constructed with the structural steel. So as you can see, there are different members used to construct the structural steel, right? And your duty as a quantity surveyor is to measure each and every members on the structural steel. Now if you look closely, right, you can see that there are different kinds of steel used in this structure. Like for example, this steel here is an I section steel because it looks like an I. Then if you look at this one, you will see that this one is an L section because it looks like an L, right? Then same with this, an L section steel because it looks like an L. So ideally, from what we can see here, is that the columns, right, the columns are the ones made of I section steel, and then the supporting beams on top, right, they are made of I section steel. And I don't know if they are the same size, but if they are not the same size or weights, you have to separate them. So you are measuring the column separate. As you are measuring the column separate, you are measuring the supporting beams separate. So you can see that from on top, there are two supporting beams, right? The beam going like this and the beam going like this. So there is a primary beam and a secondary beam, right? So you can see the primary beam going like this, you can see the secondary beam going the opposite way, right? So another thing you have to take note of is the ladder, right? So you can see the ladder too was made of what? Of L section steel, right? So this L section, like I said before, I section steel, whatever the type may be, is measured in what? Linear meters first before you convert it to kg and then to tons. So in questions or in drawings, when they give you drawings, the engineer will specify the weight. So if you see like this now, he will tell you that the weight of this member is so let's just say 110 kg per meter. So because of its kg per meter, you have to first determine what is the length of these parts from here to here, right? And then you can now add them together just to get the total length of all the members used to make the ladder. And the same goes for other members, right? So let me just start with the plinth. So you can see this concrete plinth. This is not the first time we're measuring concrete, right? So concrete is measured in what? Cubic meters. Inside the concrete, there's a reinforcement, right? So you know how you measure reinforcement. Reinforcement is measured in tons. So you get the length of the reinforcements, get the stirrups inside of the reinforcements, and then convert it to what? Tons. After that, you measure for what? The volume of concrete used for the plinth. And after that, you measure for what? Formwork. Now, if you look at this, how many plinths do we have? We have 4. 1, 2, 3, and 4. So you multiply it by what? 4. So the next thing now is the base plate, right? The base plate is this steel that you are seeing there, and I told you that the base plate, the weight is in kg per meter square. So what you have to do is to get the area of these base plates and then convert it to kg and then to tons. And you can see how many base plates we have. Since there are 4 planes, there will be how many base plates? There will be what? 4 base plates, as you can see there, right? So maybe in your drawing you are going to be seeing base plate is, let's say 50 kg per meter square. So they are going to give you the dimensions for the sides of the base plate. So let's just say this is 100 by 100. So 100 times 100 will give you whatever you have as the area in square meters. Convert it to kg, convert it to tons. So as easy as that. As for the I section, okay, before we go to the I section, you can see the hold down bolts, right? The hold down bolt is welded into the reinforcement inside the plinth, and then it is now screwed to the base plate, right? So this base plate now is what is going to be holding the column, right? Then from there, to measure for your column, like I said before, you determine what is the weight. The weight will be given to you in your drawing. So the unit will be in kg per meter. So all you need to do now is to get the total length of this column from the base plate down to where the supporting beam on top is. When you get the length, you multiply it by 4, because there are how many columns? 4 columns per 4 columns for each of the 4 plinths, right? So when you multiply it by 4, you convert it to what? Kg and then to tons. It's as easy as that. Now the next one now is what? These supporting beams here. So the same thing, the unit is in kg per meter, right? So all you need to do is to get the length of this supporting beam from here to here, get the length of the other side, get the length of the other side. Then you can see that there are how many. So we have this 4, and there are how many places? 1, 2, and what? Is there another one on top? Yes, 3, right? So it will be what? 4. The length of this 4 under here times what? 3. So it means that each of this member is going to be multiplied by what? By 3. So this member here multiplied by 3, that member there multiplied by 3, this member here multiplied by 3, this member here multiplied by 3. That is when you get the length of each. And when you get the total length of the steel that is used for this, primary L section beam, right, you now convert it to what? Kg and then to tons. So similarly, when we get to the beam on top, right, the beam on top is also an ice section, but the issue is that we don't know if it is the same size as the ice section used for the column. So the beam, right, is the same method you use to measure for your column, kg per meter. So since it's kg per meter, all you just need to do is to get the total length of the beam, right? When you get the total length of the beam, you can see how many beams do we have. That's beam A. We have this type and we have what, this side, right? So when you get the length for this one here, you multiply it by what, 2, and then you convert it to tons. So the same thing applies to the other one going like this, right? The same way, just get the weight. When you get the weights, get the total length of all the beams. When you get the total length of all the beams, convert it to what, kg, and then to tons. So it's as easy as that. The same applies to the railings, as you can see from on top. Let me get a better view. So as you can see the railings on top, right? That's this thing. It is the same process like we measured for the L section beams, right? So you get the weights, the unit is in kg per meter, get the total length of all the members, convert it to kg, and then convert it to tons. The gauze net there, it can be steel, right? Just like the one we have at that side here. That one, it's the base where the water tank is standing is made of what? Steel, a steel sheet. But this one is made of a gauze net. So the gauze net is measured in meters square, just like when you are doing your building construction. It's measured in meters square. So just get the area, and that is that. So that is just the idea about measuring what structural steel water tank stand. In our next video, we're going to be going into the measurements proper. So thank you for watching this video, and we'll see you in the next video.